There's something you need to know. Your Wi-Fi, or in this case, your network, is not only dependent on just the router and the access point. What I mean is the client devices in your environment also play a significant part in how your Wi-Fi experience would be in your specific environment, especially if you're an enterprise or an office environment. Don't understand what I'm saying or you don't believe me? I'm going to show you a demo first. Let's start with this demo. All right, so Wi-Fi's operate with something called a supplicant. In this case, your radio in this device. This specific device has a radio inside, and you can design and control how you want this device to respond to your network. And that means it's called a supplicant. You can access your supplicant through software, typically what we'll call device manager. And right under here, you're going to see network adapters. We'll specifically target my Wi-Fi adapter. We'll go to properties. We'll go to advanced. And you can see right now the Wi-Fi is operating at 2.4 gigahertz. Most supplicants or most adapters allow you to choose between 5 gigahertz, 2.4, or dual band. It is very dependent on your device specification. You have to be very careful about that. That's why it's important you choose the right device. You can see the exact same SSID. No difference. I have it plugged in at 2.4 gigahertz. Watch. We'll perform a speed test and you'd see I'll average maybe about 10% of the bandwidth. In this case, I'm averaging around 10 because I have a gigabits bandwidth. I'm going to edit that same hardware properties. I'll put it on a 5 gigahertz spectrum. Same SSID. I'll press OK. Now, there's a lot more you can configure in this supplicant, but I'm just showing you the most basic overview just to help get the point across. SSID is going to get connected. Good. We'll perform the exact same speed test on the exact same SSID. Watch the complete difference. You're looking at almost what? 7 times? 8 times the exact same speed, the same exact SSID, the same exact network. But by designing and controlling how I want this device to respond to that same network, I'm getting almost 8 times the speed of the exact same network. Why this is happening is something that I'll break down in the next clip. Stick around, okay? All right, I'm going to show you what's happening and what's going on. First, we're going to draw the Wi-Fi. In this case, we're going to use Wi-Fi because we're talking about SSID. How am I drawing this shit? I'll do it again. Okay, this is your access point. Your access point broadcasts signal. And you have your laptop. Okay, this is the laptop I was using. These laptops also have an antenna. This is a, pictographic antenna. Do not kill me for it. This access point also has its own antenna inside. Remember, this is not exactly how it looks like. I'm just using it as an example. In most access points, you'll have an antenna that sends, all right? And you have an antenna that receives. So we're going to use this case, for example. This sends back. So this is the receive. This is the transmit. So we're going to put TX, RX. This is RX, TX. Okay, now what happened with that video I just showed you is we're able to manipulate, because this access point right now is transmitting 2.4 gigahertz in terms of the Wi-Fi. This signal is 2.4 gigahertz. And at the same time, it's also transmitting 5 gigahertz. Okay? Any client that's able to capture this signal and has the right passphrase, which is typically WPA PSK, all right, WPA2 actually, they'll be able to authenticate and get into this client, which most access points are connected to a switch. And that switch is connected to a router. And then that router is connected to your internet. So the Wi-Fi signal will hit this device, transmit to your access point, goes to your switch, goes to the internet. What's going on is this device, you can also tell it, hey, I want you to capture signals in 2.4 gigahertz. Remember, this is the receive antenna. All right. I want you to capture in 2.4 gigahertz, and I also want you to transmit in 2.4 gigahertz. The problem with this is if the speed of your network is about 1 GB, which as you saw, 2.4 gigahertz on Wi-Fi has a cap limitation, which means even though you have a 1 gigabit speed, the Wi-Fi and the entire way 2.4 gigahertz operate because it can only send using DSS, a specific Mbps, which is typically classified as your data rate, which is not your throughput. Then within the data rate, it breaks it down to give you your throughput, which is received with this device. In any case, 2.4 gigahertz limits a lot of that throughput, which is why we were only averaging about 100 megabits per second. Now, what happened was when I told this antenna using the supplicant, which is the software, hey, I don't want you to receive on 2.4. I want you to receive on 5 gigahertz, strictly 5 gigahertz. Now, this antenna has the potential to transmit the same data at a much higher throughput, which is why we were getting 1 gigabits per second, because 5 gigahertz allow for more data rate. I believe 5 gigahertz can support up to 6,900 megabits per second. Don't quote me on it, but it's quite a high amount. It's in the thousands. And then I can tell it within that thousands, because my entire bandwidth only falls within 1 gigabits per second, it means it's able to support the entire throughput, which allows me to have a much higher data rate. That's why I was getting up to a gigabit per second. But in some cases, most people leave their antenna to choose between 2.4 gigahertz or 5 gigahertz. This is what you call dual band, all right? They're called dual band. Dual band means you allow your antenna to choose what signal to use depending on what's the best, especially if you're roaming. Now, this is another entire conversation that I don't want to talk about. I'm just explaining and breaking down what happened in that exact video. You need to understand that your Wi-Fi and your network performance, it's not only reliant on what's going on here. This part could be excellent. You could have a solid network infrastructure, solid cabling, solid access point, but then you have a device that only allows, for example, a single band. And perhaps that single band only supports SISO. SISO means single input, single output, compared to MIMO. MIMO means multiple inputs, multiple outputs, which is typical in 5 gigahertz. In that situation, this device becomes a limitation, not only to this device itself, but to every other device within this network. Because remember, access points operates in a kind of sequence. It has to wait for this device to finish transmission and receiving before it can transmit to another device. So now this one single device can become a whole bottleneck to everything that exists within this area. I know it's a lot of information, and I'm sorry if I didn't break it down and I zoomed through it. This is a one-take video, but I felt this was a good information, especially to IT administrators, network engineers, people who support network infrastructures in businesses or in enterprise. You need to understand that when you design your network infrastructure, don't only take into account the network infrastructure side, take into account the actual devices that will be connecting to the network infrastructure. So that way you can design special SSID, do some rate limit, QoS, whatever you need to do to be able to manipulate those devices so they don't cause a congestion in your network. Thank you for sticking through the video. Sorry for blurting out. If you want to find out more or learn more about what's going on, I'll try my best to keep putting more educational videos like this and breaking it down as much as I can. Stick around, subscribe, like, share, do whatever you need to do. And thank you for sticking to the end. Peace.